Now, PDFs you're thinking of doesn't stand for probability distribution functions, but in stats, PDF stands for probability distribution functions. We're going to be looking at probability distribution functions for a while. We're kind of getting into inferential statistics now. Still has to do with probability that we've been looking at over the last week or two. But we're going to be doing PDFs for discrete random variables today. When we're looking at PDFs, I just want to introduce them today. There are two rules. First rule is that each probability is between 0 and 1. This was a struggle on the quiz, like we already talked about, getting that probability between 0 and 1. And the 0 and 1 are inclusive. So it's okay if the probability of something is 0. You know, the probability of rolling with those pigs, the probability that we rolled an oinker, we didn't roll one, so it was 0 as far as we know. All right. And it's okay if the probability is 1. It won't happen very often, but it can happen. The second rule that we have to check is making sure that the sum of all the probabilities is equal to 1. So I want to have every possibility listed out that could happen. All right. So that way, if I add up all my probabilities, all my percentages, my decimals, I equal 100% or I get 1. So a child psychologist is determined or is interested in the number of times a newborn baby's crying wakes its mother after midnight. So they went out and sampled 50 mothers, and the following information was obtained. I'm sorry that's small. Hopefully that looks bigger on your screen. So X is the number of times per week a newborn baby's crying wakes its mother after midnight. So in this example, X is going to be 0, 1, 2, 3, 4, or 5. Hopefully, well, that's over a week. I would definitely need something higher for my kids. They woke up about every night. So I just want to know, is this a probability distribution function? It's just a simple yes or no, but you'll have to back your answer. So what was the first thing we have to check for on PDFs? I need all my probabilities to be between 0 and 1. So here's what I'm looking at. This column represents the number of times that the baby woke up. And this is the number of mothers that happened to. So 2 out of the 50 mothers, their baby slept all week. All right, that would have been nice. So it didn't happen very often. 11 out of the 50 mothers, their baby only woke up 1 time. So this is the probability that each of these X's happen. And so I'm needing to make sure that all of these numbers in this P of X column are between 0 and 1. And sure enough, 2 out of 50, 11 out of 50, 23 out of 50, 9 out of 50, 4 out of 50, and 1 out of 50. All of those are between 0 and 1. So you can just say all P of X are between 0 and 1. It's not bad, is it? Second thing I want to check for is what? I want to make sure all these probabilities add up to be 1. So if I take 2 out of 50, and if I add that to 11 out of 50, let's see, that brings me up to 13, right? And I add that to 23 out of 50, that brings me up to 36. And then add that to 9 out of 50, that brings me up to 45. Add that to 4 out of 50, I'm up to 49. Add that to 1 out of 50. Yeah, that gives me 50 out of 50, which is 1. So if both of those criteria are met, the answer is yes. As soon as you get one of them to fail, deal's off. The answer is no. Don't have to show me the other one. Just put no and tell me which one broke the deal. Can I put that on the test?
Yes.
Week and a half from now? Okay.
I can do that.
Okay, let's try to work it in reverse. They're going to talk to me about a PDF. I want to construct a PDF table. So this guy named Jeremiah, he has basketball practice 2 days a week. And 90% of the time, he attends both practices. However, 8% of the time, he only attends one practice, and 2% of the time, he doesn't go to either practice. So I need to establish an X. I need to know what values X takes on, and then make a PDF table. All right, let's start with X. What should X be? What is varying in my example here?
Practice attendance.
Practice attendance, okay. Let's days. Yeah, let's throw that in there. So like number of practice or number of days. Practice is attended. Oh, attended. There we go. And it says what is X and what values does it take on? What you can do for what values does it take on is you can just go ahead and come down here and make a probability table. Okay. So what are the different values? What are the different number of days that he attends practice? 0, 1, and 2. There's only 3 of them, right? So what's the probability he attends 0 times? 2%. Oh, I did it backwards, didn't I? That's all right. 2%. So it's perfectly fine to write this as a decimal. It doesn't have to be a fraction like we had on the last one. How many times did he go one time? 8%. And so he goes both times. It says 90% of the time. And that'd be a PDF table. Kind of check it. All my probabilities between 0 and 1, and they add up to be 1. So I'm set. Practice that so it's in your brain. That's going to be your Where's Waldo on this next test, is find this problem and get it right. All right. So work with you're going to have to be able to list out both conditions on a PDF table and tell me yes or no. And you'll have to be able to construct these. And we're going to be working with these a lot next week as we wrap up the unit. Okay.